All right. Who is familiar with XZHack? Great, almost everybody. March 2024, just a month before XZHack revealed, Hugging Face, of course, is extremely popular AI models marketplace, and it has the handy CLI interface and this implementation in Python, which is great. Now, Graph Translator was a project that actually used AI code assistants to generate some of the codes to include the dependencies in it, and unfortunately, or apparently, the AI generator hallucinated and included pip install Hugging Face-CLI instead of the legitimate command that you can see on the upper screen here. Okay, and one of the researchers leveraged it and actually created this fake PyPI package to prove kind of this concept or hack that AI can hallucinate and include dependencies that you're not intended to. Now, how do you select your dependencies? Welcome everybody to today's talk. Happy to see some smiley faces here in the afternoon. We are survivors, almost end of the day, or the second day. And my name is Roman, and I work for Red Hat. Also, I do a lot of things around security. I support open source projects, and I used to work in the companies like Intel, where I also used to be in charge of security processes, AppSec, pen test, and all the way. Today we're going to talk about dependency selection and, of course, leveraging open source tools to do so and how to automate it. We are not going to talk about SCA scans today, but rather about the health of the dependencies or the open source ecosystem as a whole and how to approach all of this. All right, I believe this is kind of what was showed yesterday, right? Some of the tremendous amount of money of value which could have belonged to 5% of Forces developers, right? In addition to this, we have these numbers. It's actually a relatively fresh report by Black Duck that almost 100% of the code bases contain open source, which we're not surprised, of course, quite obviously. Vulnerability and security problems definitely exist, and again, some of the scary numbers that we probably know. 86% of code bases contain vulnerable open source, for example. Also, we have some licensing problems, right? 56% of the code bases had license conflicts, which is also not good. And I think one of the most important outcomes of this report is maintenance and operational risk. Like a lot of codes that's developed internally that contains outdated open source components, and with the versions well behind the current date. Now the question that still may exist. Wait, I don't have that many of the dependencies, right? Why should I care? I have 3 of them or 5 of them. Actually, this is not true, right? If we, I just used yesterday devs.dev portal and tried to understand what dependencies KubeVirt client Go for KubeVirt has, and this is kind of graph of the dependencies. A few dozens are direct, but others are actually indirect. So I think this is no question anymore. Why should we care about that? But yeah, when things like XZ happens, and that was a major wake up for the industry. I think the next one after Log4j. Why should we care about dependencies? Why should we care about maintenance of the projects? And you know what? Even after a couple of years, this vulnerability still exists in the wild, right? This is like information, I think, from the last quarter of last year. 30% of active Log4j installations still run vulnerable version of it, so it could be hacked. Interesting stuff that we are all dealing with. Who knows what's on the picture? Exactly. This is actually a picture drawn by my friend Fukami of OpenSSF, but I think currently it becomes more like a meme that we share along the community to show the complexity of that kind of regulation, and of course supply chain regulations like EU Cyber Resilience Act and others that are happening actually around the world will demand or drive solid dependency management from us, from all of us, whether or not we work on open source or in the companies on the products. So there's no question why we should care about dependency selection and understanding what we consume and how to select it properly. Now, software development is not quite simple, right? But if we simplify it in the two blocks, we do codes, we do builds, we do deploy, then we go over to production and try to improve things in production. And some of the bad things could happen along the way, and you know, a lot of good frameworks around that exist if you want a more or if you want a more academic approach to that. But generally, at build stage, that's entirely possible to inject malicious libraries, unauthorized code, compromised builds. At the deploy stage, we have vulnerable kind of container images, for example, which we build then our products on, policy violations, licenses, and etc. At production stage, we have all these operational issues, right, that can come up, also 0 days, configs, compliance, and etc. But it all starts with the code, okay? It all starts here, it all starts with dependencies, and of course we have more than one problem to deal here also, to make sure our robust security posture there. That could be malicious code, that could be vulnerabilities, dependency that are unhealthy, repo compromise, and so on. And we are going to be focusing today on this, the very first part. Because I think for the others, we also have extensive discussions and good solutions, but the first part is often overlooked, right? We quite often scan at the very end, okay? Now, a little bit stepping back, and even before we start coding, I want to share this story, if you're not familiar with. Hopefully you're familiar with what's this, right? This is VS Code. Quite popular idea, right, that we, some of us working in. And this is the plugin, one of the plugins, one of the beauty of all of these IDEs, right, Cursor with VS Code, that we can actually download some of the great plugins, and one of them was Dracula plugin, and if you're attentive enough, you can spot on what's wrong in this, because it was actually Dracula, not Dracula, and again, typo squatting is a very popular attack. At this time, that was also a research project, right? Some of the researchers that just posted a similar extension to VS Code to the marketplace, and then saw what happened. And what happened was brilliant. I think kind of thousands of downloads, if not millions. And this is the map that this researcher built, potential victims of downloading this this extension. How did he find, or she finds, this person finds this? Because the research project included like malicious payload to this plugin, along with the nice dark theme that was a malicious payload, collecting some information about systems, users, and etc., and sending it over to what could be command and control server of the attacker. Again, thankfully it was a research project, but you can see how it was spread across the globe. So the first outcome is take care of your dependencies from the very beginning, even before you start code. Validate all the extensions. Thankfully, right now VS Code has some of the guardrails in it, but still trust but verify. Now, when you start thinking about dependency inclusion or about the projects that you're going to leverage in your environments, they're going to install, they're going to use somehow, right? Probably the first thing that we do is we go to the repo, right? Whether it's GitHub, GitLab, it doesn't matter. We go to the repo and we try to spot on some things. I just brought the example of KubeVirt, which is a virtual machine add-on for Kubernetes, quite a nice project, and it would be a good example. Probably we wanted to see some of the things here, like code of conduct, whether it exists at least or not, licenses, security, MD file, and all of these nice badges you can see on the top, whether it passed or not, some of the checks. Then we come across this right side of the repo array. We see the stars, of course. We see releases, whether or not project does the releases or it just release out of the main, which is like not a good practice, right? How many contributors this project has? Now, it's probably good to see where was the last commit, right, and what it's all about. Then see the description or README file of this project, whether or not there is a website, like any community efforts is happening around, how docs would look like for this project, right? Whether there are another information about that, then community. Whether or not it has some of the channels that you can communicate easily, how to contribute, how to engage, whether there's extensive discussions happening there. Probably the project could belong to some of the foundation which could be additional proof points of the quality of this project, not necessarily, but like an additional argument towards it when you select, right, your dependency or your project you're going to work on. Now, I think you already kind of stopped a little bit to follow, right? What exactly we should look for when we select open source projects to include in or to use. Did I say that we must research, we must do the entire research for all the dependencies and actually for all the versions of all these dependencies because they are evolving and what is true for now could not be that true tomorrow with the next release, for example. Okay? That's a good question. Let's try to answer this question. Of course, the answer is it depends, but hopefully not, because we have a large amount of open source tools that's available right now that you can use to assess the health of your dependencies, the health of the projects that you're going to use. And the first tool is OpenSF Scorecard, quite famous. Who is familiar with OpenSF Scorecards? And who use open source scorecard? Okay, less than familiar with. I encourage you to use this tool. I implemented OpenSF Scorecards for several projects and several companies that I worked for. Very flexible tool, to be quite honest. What it's all about? Actually, this tool represents good development practices. They're all connected to security, but if you have a look at the scorecard, which now has a fancy UI interface, basically you can use these project as a UI, you can run it as a command line, you can run it as a GitHub action, for example, you can automate it in your own way in your internal CI with no problem at all. And if you can, if you look, have a look at the checks that it performs, they're all kind of good practices, right? Whether or not you do the code reviews, whether or not you turn on your SAST scanner, for example, CodeSQL, like default scanner for open source project in GitHub, whether or not you handle vulnerabilities in your project, right? They're all good questions that are more and less good development practices, despite the fact that they are connected to security. And this tool would set back the aggregate score based on these indicators, based on these checks that are performed automatically for the given repo. And that score could be from 0 to 10 based on the criticality of each individual checks. And this tool is not meant to be like green or red necessarily, right? But it could give you a kind of idea what project is doing about security and about good development practices. And to my experience, all the scores that are more than 7 are generally good. If it's 8, 8.5, this is kind of tremendous. But more than 7, it's good. So the practices are there. One suggestion here, if you use scorecards, again, I worked with this project a lot, and so like a pushback, okay, we don't use necessarily all of that metrics, and you don't have to focus on the metrics. That's really important to you, because you can have your own opinions, you can have your own specifics, and it doesn't necessarily fit to all the programming languages well, for example. Okay, so use it wisely, but I really encourage to use it. Now the question would be, okay, let's pretend I implement scorecards for to check some of my dependencies, like in more automated fashion, right? Rather than open your eyeballs as I showed in the previous slide. How about the consistent process? How about implement this to check each version of the dependency and check all of the dependencies at scale? And also there is a solution which is now kind of proof of concept, but already works. Again, hosted under OpenStack, that calls Scorecard Monitor, which scans organizations, the entire organizations that is scope, and looking for repositories that are available, and leverages the OpenStack scorecard. It looks like this, like in a very friendly manner to us, to developers, and after the scan you have this nice table with all the links. Actually, that's all stored in the database, and it's all version by version. You can see at the top left of the slide the commits, so it's performed against commit or whatever milestone you would like to. It generates an issue automatically, should you desire so. It could be automated by a custom trigger or by cron job running inside the CI system or action, for example. And for each kind of scan, for each commit, it shows you the scorecards, all insert scorecards, so that you can compare it actually to the previous versions, right? Whether or not that was some improvements or otherwise, which is quite handy, which is quite good. Again, this idea is very brilliant, so just go ahead and use it. Yes, and also it generates issues for you. It could even you can even trigger PR generation after it. However, advice here is don't forget to test all the proposed changes that you're about to make. This is another kind of pitfall from my own practice, why people tend to not use tools like this, because often the case, the changes are actually breaking changes, and it doesn't help you, right? Maybe they try to reduce security risks by they introduce some breaking changes and your code is not going to work. Test all the time, and my personal advice is to, it should be tested, it should be workable, otherwise, the security is useless there, right, if it doesn't work. Now, another good project also happening in the OpenSF is repository service 2. That's called, this is a service actually for secure downloading, installing, and updating contents from third-party repositories locally. This project was originated by idea to handle somehow the curated set of repositories like a mirror internally, or otherwise have metadata about the packages and dependencies that you ingesting directly from the respective package manager. It is available as a server. You can go ahead again and check the project. It's open source. It's all available. It works pretty fast and pretty easy. And yes, it is not yet another CI/CD system. Again, it can sound like, okay, I have my own CI, I should use another stuff. It integrates very much well and works alongside existing CI systems via REST API, which is kind of good. But yeah, it provides like an additional instrument or additional service to manage your third-party dependencies locally before you're going to ingest them into your project, into your code. Now is going next another useful tool, package analysis, which is, I think, not at that active development right now, but I would really like to share an idea with you because I've seen some of the kind of internal implementation of this approach. This also approach is really good. And again, it comes from the idea like, why couldn't I just check what all these dependencies are doing before I actually ingest them to my either internal repo or directly to my product? Remember this malicious PyPI package, remember these malicious extensions and everything that could be checked for the malicious behavior upfront. Even if you are not catching these, like, because the attacks like type of squatting really hard to catch, right? Why don't I implement antivirus-like approach, actually assessing how these packages or dependencies behave? This particular project that I'm showing off on the picture is package analysis. I think currently it supports NPM, PyPI, and Ruby gems, and it tries to answer the questions: what files does this package access internally, for example, in order to understand whether or not it's accessing, like classic example, whether or not this Torch application for your phone wants to access your SMS or does the call, right? What addresses does this package connect to? What commands does this package run? How does package behave over time? Which is also kind of important. And again, this is an idea to actually, like, comes from anti-malware software, sort of speak, but leverages specific of how these package managers work and how the development flow works. Initial goal of this project was to study behavior of open source packages, like in general for their open source good, so that it's kind of community hosted service to check all the publicly available packages. But again, it could be installed locally because the idea is good, and if you use this approach of mirroring dependencies internally, curating them, it's a good approach to do that. And yeah, this is one of the example what it's all about. For example, it could help you to understand or detect a remote shell kind of connection that could maliciously be opened against your repo. And again, it leverages the past experience of these attacks that we were talking about. The project intends to leverage this knowledge so that to test against these past attacks, similarly to the packages that you were ingesting right now. Kind of cool thing. All right. That was the security part. I can talk about security for 3, 4, 8 hours. I've been doing security for 17 years now. But is security all that I need to care about when I do my dependency selection? And you can kind of pretend the answer is not really. Security is a big part of the dependency selection, but nowadays it's very important to look at something else. What does it mean well-maintained projects? I think we have been talking about that over the entire 2 days of the conference, right? How to support ecosystem and what the future of the ecosystem if we don't come together and support it. Because, we can have either this picture, which is actually pretty nice ruins of castle, in Clinton County, Galway Islands. I'm coming from Ireland, so I visited this site. It's kind of beautiful, but I do like more visiting Kilkenny. Actually, also in Ireland, and you can kind of spot the difference between them, because it is very important to think about the level of maintenance and the overall health of the project. It is connected to dependency selection in the way that you probably wanted to use the project that's well maintained, and you probably wanted to leverage the dependencies that tends to be well maintained in foreseeable future. Right? It's hard to predict, but I'm going to show some of the ideas how we can at least try to do it. Because community health metrics really give a good idea about projects past, of course, but also about the future. And kind of coming back to top open source software dependencies concerns that typically we have, right? At the company's licenses, I mentioned it, vulnerabilities and overall security posture, we talked about that, and other maintenance projects, which is very important, but we don't talk about that, I think, that often, right? And here I wanted to reference to COWS, which is also good open source initiative. COWS stands for Community Health Metric Analysis in Open Source Software. You can check this website, it's very well made. What it's all about. Currently under COWS there are 89 community metrics that can eventually refer or show you the project life, right? How the project lives. And there are kind of different metrics spanning from like pretty obvious, like starting from stars and PRs and contributions, but also it operates like how issues are labeled, what is the test coverage, collaboration platform activity, conversion rate, and etc. Which is kind of good to understand, again, to feel how project lives, in order to answer the two main questions. First of all, whether or not I'm comfortable to use this project, and second, maybe I can help this project somehow, and these metrics can show you exactly where help is needed. One example, one of the metrics is time to first response, for example, that answers the question how much time passes between when an activity requiring attention is created and the first response. Okay, kind of SLA. And it's very good to measure. It could be measured by collecting timestamps, by collecting activity tracking, for example, in GitHub and GitLab, or via additional information if it's available somehow in the open. And at the top of the slide, you can see an idea how this could look like at the dashboard. Chaos projects is actually comprehended by a few initiatives that help to convert this metrics idea to the tools. I will be showing you some of the brilliant tools just in a moment. But this is like how it can look like on your dashboards, for example. Okay, this is kind of more enterprise level, but to show you where I'm coming from. Again, it's all open source. Please do not hesitate to check github.com/chaos, and of course all the contributions are very well desired, whether it's to metrics, whether it's to some of the concepts, to research that is ongoing there as well, and most importantly, I think, at the current stage, to the tools that can support these kind of metrics to be automated, to be leveraged in the or adopted by community and by companies. This is another example how it could be used, right? For example, if we spend like just these 7 metrics that I'm showing off on the slides, that are kind of including backlog, management index, review efficiency, again, lead time for issues, median lead time for pull requests, which kind of alone can basically show nothing, but if you can combine them together, it would make sense to compile the aggregate scores that you can then attach as the kind of labels to the dependencies that you are using, right? And then to say, hey, these 2 dependencies are green and very much healthy, these 2 are red, and I'm going to do something about that. And as I mentioned, I encourage everybody, even if you work for a commercial company, to go ahead and think from 2 perspectives for these dependencies that are quote-unquote red flags. Try to understand how to help them, right? Rather than just, okay, I'm going to do the next one. So this is a kind of the example of the necessary metrics, and also on this slide, please pay attention to the last bullets, how community can address the talent retention, for example. And all metrics could be collected. It's a little bit harder than collect just a number of PRs or time and duration, but at the end of the day, they all will show up, will show you the kind of health and trends, and for example, if any help is needed, if any specific skills are needed there, or at least if the project loses like the contributors. Right? This is very good to understand and very good to track actually. Now, we're talking about dependency selection at scale. Okay? That's why understanding the metrics is very good, but how to actually scale it, how to use it in practice. And here I'm going to refer to the projects that are connected to chaos that I showed on the previous slide. And the first of all, this is a project called Ogre, which is actually a database and data science powered engine in it. So it collects all the repo information and organizations in a curated way, in a validated and verified way, so that this data then can be used as a metrics on the dashboards or otherwise in your organization as you develop your products or your projects. And one of the cool UI project that supports chaos metrics and that connects that is connected to Ogre is Eggnog, which is UI, basically interface dashboard-based dashboard with a structure to visualize and analyze those data about open source repos. The good news here is they are all open source projects, right? And kind of news here, they all would really like more contributions. so please go ahead and check it out. I don't have like a big demo of it, but I would like to show how at least it looks like. There is a instance, cloud-based instance, like a proof of concept for the 8 node, right? It's not production instance, but how it look like? Let's try to use our KubeWeird project as an example here. I'm searching up for the project and see whether or not it could pop up data for me here. Yes, and we can see registration at all, but we can see at least the languages, right? We can see the other kind of basic statistics and OpenSet scorecard. Actually, I owe the answer to a question from one lady from yesterday. Yes, 8 node supports scorecard, not for each, you know, not for each historical scans, but for the latest one only at the moment. But yes, it supports it, and Over also supports it.
Thank you.
You're welcome. So this is kind of general info, but if we are diving a little bit into the details, we can actually spot on them some of the essential metrics that I just mentioned a couple of minutes ago. Let's see, you can see here commits over time. Let's see issues assignments. And yes, this is kind of interesting. Pull request time to first response. And we can see that these projects is actually handling very well pull requests. So the kind of yellow line on the top line, it shows the PRs open, and the little pink line shows that responses less than in 2 days, and these graphs like very close, which is very good. That means that's for a lot of issues, a lot of pull requests, this project responds very rapidly, which is awesome. Yes, you can deploy it on your own. You can play with this tool, but also you can deploy it internally because all the code is available. If you're having suggestions, they're very much welcome. All right. There are some of the tools that could help you to get an idea about your dependencies, about the selection of dependencies. What else is happening, and what I see would be the future of it, especially in the light of regulations that are happening right now, and especially within the tremendous demands of the handling and ingesting all of this information around your dependencies, around your SBOMs, CDs, and etc. So, kind of the future of open source software security posture. This is the project called Security Baseline, which is basically the set of the good security practices that could be implemented to the repo. They are not necessarily all technical, as opposed to OpenSet scorecards, when you have these kind of really technical questions that could be checked automatically. For example, whether or not project has signatures, whether or not it has releases, whether or not it handles vulnerabilities, and so on. Security Baseline, it's about the overall good practices about the project, and it's called Security Baseline, but actually it contains also kind of legal governance and quality and build of release and other set of standardized requirements. And there are currently 40 requirements across 3 levels of maturity. It kind of also could be used as a benchmark along with as a framework, covering 8 areas of security practices. To give you an idea, for example, one of the security practices, right? I'm reluctant to say this is a requirement. Again, this is more or less practice. For example, when a CI/CD task is executed with no permission specified, the project's version control system must default to the lowest available permissions for all activities in the pipeline. Kind of least privilege principle, right? which I think should make sense for pretty much all of us. And this is from the level 2 requirements. So remember there are three levels. To reach level 2, it's not really a big problem for the projects, to my personal opinion. Level 1 is just really basics. Level 2 is also not really big problem if the project is healthy and have like standing kind of release canons and good contributions level. Contributions levels. Level 3 is kind of also achievable, but again, at least level 2 is achievable 100%. Another project that was actually originated a little bit before security baseline, but I think now connected to this, called security insights specification. Idea behind this project is to basically create this specification in the form of YAML file when projects would be able to declare their security practices, like whether or not I do threat model, and this is the link, whether or not I implement some of the other good security practices, and security baseline comes handy here, right? This notation, this YAML file could point you out, okay, I'm at level 2 and this is why, right? This is kind of my declaration. And it's meant to be in the machine-readable format so that when I do my dependency selection, okay, I can leverage this information and have an idea about the security posture of this project. But again, I keep saying that it actually goes beyond security. It goes for overall good practices, quality, governance, everything that could happen to the projects. And again, in the light of the CRA, for example, it would be a good idea to recommend ideas like these to the open source projects in order to declare that they do or they comply with essential cybersecurity requirements, with vulnerability management requirements, and SBOM requirements, which are three major requirements coming out of the CRA. This is not only projects, and thank you for pointing that out, guys, from Cyclone DX, also working on open source software sustainability, which is kind of connected to that, basically to create a standard that can allow open source projects to say, hey, we need this, and that to make our project more sustainable. Okay, and declare and communicate this in more standardized way, so that consumers, again, connected to dependency selection, me as a consumer, I can have an idea what project needs most or what it has already, for example, as a good practice implemented. Okay, how else to scale dependency selection, right? Beyond the understanding metrics, beyond the tools that we can leverage. Based on the, I think, last Linux Foundation Software Security Education study, actually 28% of professionals directly involved in development are not familiar with secure software development, which makes me sad, because I have built security champions programs for quite a few companies, but it's still not there. Another good study performed by the company JIT.io, and one of the questions that they asked in their study, what are the biggest challenges you face when it comes to securing your code? Okay, just a very broad question. And they also asked to rank these answers. Complexity of modern application architecture in the first place. Yeah, complexity is the biggest enemy of security, unfortunately, but we should handle it because, you know, we of course wanted to innovate, wanted to build more cool stuff. Third place, lack of organizational priority. Fourth, lack of the time, and next, lack of automated security tooling, which is still a problem, but hopefully now you have a better idea. And you're wondering what's on the second place, right? it is lack of knowledge, training, and guidelines. So pretty much high in the rank of, of the responses. Why? What prevents me as a developer to make my code more secure or my applications more secure? Okay, and there are a couple of answers to that. Also, education is a really, really big part of the improving overall security posture. Everything that I was talking about could be kind of educational falls to developers, because me as a security person, I need developers to help me. I can't scale myself, right? So, and there are a couple of good stuff that you can share or can take yourself, also happening under Linux Foundation in this particular case, but there are more, of course, educational materials. I personally was engaged into some of these classes, and we donated some of these classes as a company when I worked at Intel, and you can spot on the slides that these particular classes, they are for free. Okay, they cost nothing, but they're actually pretty good, they're actually pretty interactive, they're not that typical boring classes that may exist elsewhere, so I can personally recommend them for additional education, which, as I mentioned, could help to scale also your dependency selection at the end of the day. Finally, I promised to share some of the values. Often the case, especially when it comes to security, when it comes to some of the improvements of the security quality, governance, something like that, the companies, the question arises is, why should we care as a business leaders, for example, or managers, and what are their benefits that can be leveraged after I, for example, implement or run or start my security program or my dependency selection program? Of course, it takes some effort, right? Tools are free and open source, but it doesn't come for free, because you still need to put some effort, right, to implement this, to automate this. And this is kind of based on the true story. Development team used a relatively popular open source web framework based on this repo stars. So back in the day, they say, okay, this is kind of different options that I have to select this as a dependency for my project, and okay, this project has a couple of, maybe even a few thousands GitHub stars back in the day, and that's good. There was no deep architectural discussion about this, because why? The name is cool, the logo is bright. Now, when times come, CVs, they are starting to pop up with no further fixes, apparently, because that's, of course, CV and all this scanning was largely automated there, and typically the CV comes and the new version is there, so we can bump up the versions using dependables or renovate or whatever. Okay, but there are no fixes, and turned out projects started to die 1 year ago before this date, right? And somewhere they actually declared that, we are tired. It's kind of connected to XZ story, but it's not XZ. The complication of the story and the outcome of the story was that there was the task force and the major escalation for the development team to migrate urgently to yet another dependency, to yet another framework, and of course that was so painful, and of course that was not a really pleasant exercise. Kind of the benefits that you can gain to prevent it, and actually what's happened next. There was a guidance implemented and processes for the dependency selection, and it was also made a part of the architectural review, so that architectural review and threat modeling and all of that stuff are performed keeping in mind all the dependencies that the team leverages. The team created curated repo health indicators. Remember, I told you that pick the metrics that's important for you. Okay, and that was like a a mixture of different metrics that this team implemented. Checks were automated with open source tools that I just showed you. Metrics now support conversation at all levels, because before it was really hard to argue, but either from development perspective or from security team perspective, why I should use this or this tool. But metrics and data, numbers, essentially, they generally help all the conversations and at all the levels, at all the management levels, which is good. And then after this improvement was implemented, a team reported up to 15% resource savings handling with the dependencies, okay, because a lot of stuff was automated. Kind of things that you can show as an improvement, again, to business, to leaders, which is very important. Takeaways. Learn where the risks come from your dependencies, and repeat. So it's constantly learning. The new attacks and new attack techniques are happening every day, so it's extremely important to stay up to date. Pick metrics that's important for you. I mentioned that already. And most popular dependency doesn't mean most healthy, but curate your metrics, okay? But if you don't have an idea, use what community uses. Again, concept scorecards and default kind of installation is very good to have a sneak peek of what's happening. If you go further, pick up the metrics that's relevant for you and focus on them, instead of endlessly debating that dependency opinion, for example, is not going to work, right? Because I have some religious, opinions about it. Okay, it's not going to work. All right, let's try to implement it with something, and then return to this conversation if we would like. Automate it with a bunch of decent open source tools that's already available. This is extremely important. A lot of stuff is already available. Use it, leverage it, try it. And one of the most important points that I mentioned a couple of times already, but it's contribute back to the community with your experience. We really need it as we work along all these projects that I mentioned to you, and of course other projects. And the important point is, yes, this is very, very much relevant beyond just cost contributions, and actually, other than cost contributions, different contributions are very much demanding in a lot of open source projects, right? Spanning from kind of documentations into issues handling and etc. Come, show up and help to contribute back. And even if you contribute back with your use case for these projects, for example, at my time when I worked at Intel, we just came and show our example how we use scorecards internally to entire community. Yes, it was painful at some degree, but at the end of the day, the project was improved. So just show your experience, show your pain, show your issues. That alone means actually a lot. And if you're wondering what's this QR code is for, it's kind of our Red Hat's latest product security risk report for the previous year, for 2024, but it's just released. Check it out. It contains a lot of practices that we use at Red Hat for handling vulnerabilities in open source, for handling vulnerabilities generally. It has some ideas and concepts that we use that could be helpful, hopefully, for everybody to implement. So a lot of learning, a lot of stats, their data, kind of nice report. Please check it out. Select your dependencies wisely before someone else does it for you. Thank you very much.
Better words are never spoken. Choose your dependencies wisely. Thank you, Roman. Do we have any questions? Yes, we do.
Hello, thank you for the presentation and your great work in this area. I just have a quick question on what kind of sandboxing technique are you using when analyzing and looking for malicious payloads in dependencies?
That's a great question. That's why I more or less suggest you to try this tool project. But there are a couple of open source sandboxes that are available out there, so you can implement by yourself inside the company. And there are tools, obviously open source anti-malware tools like ClamAV, for example, actually good scanner, and you can also leverage some of the threat intel data that's available using other tools, right? I wouldn't mention something else specific because it largely would depend on the infrastructure that you are working in, and again operation systems and everything. But yeah, try to use this tool project, try to use ClamAV and a couple of sandbox open source tools that are available out there.
All right, thank you.
I know that OpenSSS tooling tends to work with Nix, for example. So they're probably using some form of container, aren't they, when they run their dependency scanning?
Yes.
At least school.
Yeah.
That's my guess.
Yeah.
Yeah, there's one of your slides that I have questions about. And that's the one where you show the dependencies, and then with each of them having an aggregated score. One of the questions I have is about this aggregated score, whether that's the OpenSSF scorecard aggregated score, or whether that's, because I think you discussed this like in the context of these other metrics, like the sustainability metrics, like how quickly somebody responds to stuff like open issues. Like, so whether it's like an OpenSSF aggregate score or whether it's an aggregate score based on all of these other metrics, that's my first question. The other question is which tool is this based on? Because as far as I know, like Over, for example, like, I mean, it doesn't scan dependencies for you. So what is the automatic tool that checks all of my dependencies based on the metrics that you're outlining?
Yeah, I'll start with that first question. Yeah, so this picture with the kind of dependency A, dependency B, etc. That was an example not for OpenSSF scorecards, but for the how these chaos metrics could be aggregated and included. And there are a couple of tools, as I mentioned, at the chaos website that you can go try. There are also should be a couple of commercial tools that are working with it, but you can have an idea. There are a dashboard how they collect these metrics. They also have a proof of concept as a web instance that you can see this. The issue here that I would suggest to avoid is to there is no one size fits all, as I mentioned a couple of times. These metrics tend to be individual for your use cases, and that's why again I mentioned that OpenSSF score kind of good, but you know, it could mean different things in different use cases. So that's why I don't know about the one golden tool that can, you know, show you this. That was more like an example of how it could be used, with a couple of tools that you can individually tune in to collect these metrics for you, instead of, okay, this is kind of red and blue, red or green. Yes, and the second question was about the scan information, the dependency information. Yes, it is not collected. It is not collected by Over, and it is not collected, you know, in the chaos framework. The reason is because there are a lot of open source tools that are available for scanning to give you S-bonds, to give you CDs, and I think those should be used kind of independently, because again, the fact that the project has a lot of CDs doesn't mean anything, right? So I wouldn't use this metric alone as a kind of necessarily bad thing. Okay, so I would suggest to use them separately then, because it's not like show you the health of the project itself, but show more operational information.
Okay, thank you.
Right. We've reached time, I'm afraid. Thank you very much, Roman. That was excellent.
Thank you.